There is a quiet shift that happens when you realize that reading something is very different from making it. You can read a recipe and still not know how cooking really works until you step into the kitchen. You can read a map and still not understand a city until you walk its streets. For a long time, biology has been like that. We have read life very carefully. We have pointed at parts. We have labeled them. And yet something has always felt missing. The context here is how humans learn complex systems. We often start by observing. Then we isolate pieces. We poke. We test. We remove one part and see what breaks. This has taught us a great deal. It gave us microscopes and medicines and the ability to name diseases. But it also led us to believe that if we just kept reading carefully enough, the answers would appear. When we mapped the human genome, many people felt that moment had arrived. 3 billion letters laid out like a complete book. Surely now we would understand life. Instead, we discovered how little meaning we could extract from reading alone. Knowing the letters did not tell us how the story worked. This leads to the first surface insight. Life is not just information. It is function. DNA is not only text. It is behavior. It folds. It interacts. It responds to context. A single letter change can do nothing, or it can change everything. This is hard to grasp because the scale is overwhelming. Imagine writing something longer than all the books you have ever seen combined in a language you do not speak, and knowing that one tiny typo could change the ending completely. That is what biology deals with every day. The hidden assumption we carried for years was that understanding comes only from reading. That if we could see every part clearly enough, we would know how it works. But this assumption ignores how humans truly learn complex systems. Engineers do not only study machines. They build them. They take them apart and put them back together. They learn by creating and failing and adjusting. When you build something, you are forced to confront reality. It either works or it does not. There is no hiding behind theory. This is where a deeper pattern appears. Understanding emerges when reading and writing meet. When observation is paired with creation. When analysis is paired with synthesis. In language learning, you truly understand grammar when you try to speak. In music, you understand harmony when you compose, not just listen. Biology has reached a point where reading alone has hit its limits. The system is too large. The interactions are too deep. This is where treating DNA as a language changes the frame. If DNA has grammar and structure, then it can be learned. If it can be learned, it can be written. And if it can be written, then we can test our understanding in the strongest way possible by asking, does this work? Creating DNA is not about playing God. It is about creating a mirror. When you generate something and test it, you see immediately what you understand and what you do not. The structural pattern here is powerful. AI does not replace human curiosity. It amplifies it. AI can hold patterns at a scale no human mind can. It can scan across vast sequences and notice relationships that would take lifetimes to see. But AI alone does not know meaning. Meaning comes from testing. From biology meeting the lab. From seeing whether something folds correctly. Whether it cuts where it should. Whether it behaves like life rather than noise. When AI generates DNA and that DNA works, something profound happens. The model did not just copy. It learned structure. It learned constraints. It learned the deep rules that evolution has written slowly over billions of years. This is not magic. It is a new kind of feedback loop. Generate. Test. Learn. Generate again. Over time, rough sketches become more detailed. The reframing here is that biology is shifting from discovery to design. This does not mean we know everything. It means we are willing to test our understanding by creating. Designing does not imply perfection. Early sketches are incomplete. They are missing parts. But sketches improve. Just like early airplanes did not fly well and early computers filled rooms and barely worked. Progress comes from iteration, not certainty. This reframing also changes medicine. Instead of asking which drug might help which disease, we can ask, what does this specific body need? Personalized care becomes possible not by guessing but by matching patterns. Instead of treating symptoms, we can change causes. Sometimes by editing a single letter. Sometimes by adding something new. The idea of adding new chapters to the genome sounds distant, but the direction is clear. We are moving from reacting to disease to designing resilience. Application to daily life might seem far from DNA in labs, but the pattern repeats everywhere. We often try to understand our own lives by analyzing endlessly. We think. We plan. We read advice. But real understanding often comes from doing. From trying small changes and seeing what happens. From building routines instead of only thinking about them. From creating projects rather than only studying success stories. The same hidden assumption appears. That if we understand enough, we will act perfectly. In reality, action teaches understanding. Building teaches more than observing. Optional deepening comes with the discomfort this creates. Creating life like systems raises fear. People worry about misuse. About speed. About things getting out of control. These concerns are real and should not be dismissed. But there is a false choice that often appears. Innovate or be safe. Progress or caution. This is not how mature systems work. Cars became safer not by banning engines but by adding brakes and rules and monitoring. Medicine advanced not by stopping research but by adding ethics and review. AI in biology will require the same. Oversight that evolves with capability. Security that grows as tools grow. The answer to powerful tools is not ignorance. It is responsibility. Humans have always shaped life. We bred crops. We domesticated animals. We altered ecosystems, often without understanding the consequences. The difference now is that we can see more clearly and test more carefully. Creating DNA does not mean abandoning humility. It demands more of it. Every success reveals how much we still do not know. Every working system reminds us that life is subtle. The deeper truth here is that understanding is not a passive state. It is an active relationship. We understand life better when we are willing to build and test and revise our ideas. This approach does not reduce wonder. It increases it. Because when something you created begins to behave like life, you feel both awe and responsibility. You see the beauty of the rules and the fragility of the system. As we stand at this edge, the questions become less technical and more human. Not just can we generate DNA, but why and how and for whom? Will we use this ability to reduce suffering? To cure diseases? To protect ecosystems? Or will we rush without reflection? The tools themselves do not decide. Our values do. Reading life brought us far. Writing life will bring us further. But only if we pair creation with care and power with humility. So as biology moves from reading to writing, from observing to building, from discovery to design, the quiet question remains: what kind of life do we want to be capable of creating and why?